Alright, and welcome to Inverses of Logarithms. Okay, so in example 1, it says find the inverse function of f of x equals 8 log base 7 of x plus 6. Okay, so how are we going to tackle this? Well, what we want to do is we always want to get the log and the function on the inside of the log, whatever the log is taking of, we want to get that by itself. So notice that here we have this 8 which is right beside it, and since the 8 is being multiplied, since the 8 is being multiplied, we're going to have to get rid of that first. Now, before we do that, let's go back to the traditional things that we would always do with a function. Firstly, we know we have to take f of x, we have to transform that into y, and then we'll say, okay, well, y is equal to 8 log 7 of x plus 6. Sorry, I missed the appropriate blue color here. And then from here, remember, what's the idea of inverses? The idea of an inverse is that you take your y and your x and you switch them. Remember, we had a whole section on this. Alright, so we switch our x and our y. So let's say x is equal to 8 log base 7 parentheses y plus 6. Man, I promise, guys, I'm trying to get that same blue color. I'm just missing it. Alright, and from here, now we start getting rid of things, okay? And so we're going to get rid of that 8. We know that 8 is being multiplied, so we're going to divide both sides by 8, and that goes away. And what do we have here? Well, let's see. We have, I'll just kind of draw a dotted little line here. We can say we have x over 8 is equal to the log base 7 of y plus 6. Okay, well, I want y'all to think back to our last lesson. How do you get rid of a logarithm? And the way that you do that is you take the base, which is this case 7, and we put everything in the exponent of 7. And what we do to the right, we do to the left. So that when I say we put everything in the exponent, I'm saying we now have 7 to the power of x over 8 is equal to, and this base 7 and the exponent of log base 7, those cancel. And we're left over with this y plus 6. Okay, now from here, we're simply one step away. We will simply subtract 6 from both sides, and we rewrite our y value as f inverse of x is equal to 7 to the power of x over 8 minus 6. Alright, we just took our one new thing that we learned in our last video, getting rid of logarithms by raising them up into the power of whatever their base is, and we applied it to inverses, and so y'all should feel pretty comfortable with most of this. Alright, let's go see another example. Okay, here we have example 2. We want to find f inverse of f of x equals 3 log base 9 of 4x minus 6. Now we know that we're always going to start this off by simply rewriting our f of x as y. And here, guys, I'm going to be a little bit better on my colors. Alright, sometimes when I'm going through these examples for the first time, I don't really have a coherent color scheme. Now from here, we know that we want to take our y and our x, because remember, guys, this is the big idea of inverses. You switch your x and your y. And so I'll put x right here, I'll put y right there, and then I'll go in and I'll write the rest of it in that same color, equals 3 log base 9 of 4y minus 6. Now at this point, now I have to get the logarithmic function. Well, I really have to get y by itself, but I start to get y by itself by simply getting this logarithmic function by itself. How do I do that? Well, y'all can clearly see I have to get rid of the 3. Okay, so since the 3 is being multiplied, we'll get rid of it by dividing, or by doing the opposite. We now have x over 3 is equal to our log base 9 parentheses 4y minus 6. And I want you to pause the video, and I want you to see if you can figure out what to do right here on your own. Just pause the video, try this out on your own. Okay, you're back, and I hope that you paused the video, and I hope you tried this. And we notice that our base is 9, and so we're going to raise everything up into the exponent of 9 itself. What I do to the right, I do to the left. And my base 9 and my exponent of log base 9, those cancel. Because remember, logarithms are the inverse operations of exponents. So now I'm just going to write 9x over 3 is equal to 4y minus 6. Now from here, how do I get rid of that minus 6? Well, of course, I add 6. Guys, we're just doing basic algebra at this point. It's a two-step equation. And I say, okay, well, I've got 9x over 3 plus 6 is equal to 4y. We have our final step. We're going to divide both sides by 4. And once we do that, y is by itself. I bring it over here. I rewrite it as f inverse of x is equal to 9 to the x over 3 plus 6, all divided by 4. And there's our answer. All right, let's move on. I have one final example for y'all. Okay, in example 3, we have find f inverse of x, where our function is 12 log base 3 of 2x plus 1 minus 7. And of course, we know we're going to start this off by simply taking our f of x, switching it to y. We'll say y is equal to 12 log base 3 of 2x plus 1 minus 7. Now here, we know our big idea is to take our y and our x when taking the inverse, and we switch x and y. We'll say x is equal to 12 log base 3 of 2y plus 1 minus 7. Now from here we have a fairly large, kind of semi-complicated looking problem. I want y'all to notice we still have to get the log base 3 of 2y plus 1. We have to get that by itself. So you'll now notice that instead of just the 12, there's also a minus 7. So our question becomes, which one do we get rid of first? Do we get rid of multiplication, or do we get rid of subtraction first? Well, y'all should know at this point we get rid of our subtraction first, and so we will add 7 to both sides. And at this point, we now have x plus 7 is equal to 12 log base 3 of 2y plus 1. And now we can actually get rid of that 12 by dividing both sides by 12. And that cancels away. Now here, I'm probably going to clean this up, so what I want you to do is I want you to pause this and finish taking your notes as I go ahead and make this a little bit nicer and neater. Okay, so now we have this x plus 7 over 12 is equal to the log base 3 of 2y plus 1, and we are now going to get rid of our logarithm. We know that we have a base of 3, so I'm going to put every single thing up into the exponent of 3, and those cancel. And what I do to the right, I have to, of course, do to the left. At this point, our exponent is becoming so complicated, I want you to put it inside of parentheses. So we can say we have 3 to the power of x plus 7 over 12 is equal to 2y plus 1. And from here, well, now we're just kind of back to the original, just getting rid of our addition first, so minus 1, minus 1. And what does this give us? This gives us 3 to the power of x plus 7 over 12 minus 1 is equal to 2y. And then we can simply divide both sides by 2. And once we do that, and y is by itself, I can write our final inverse function, which is going to be pretty crazy. 3 to the power of x plus 7 over 12 minus 1 all over 2. Alright? Well guys, I hope that this video helps, and I'll catch you guys in our next video.